Okay, we're back with proving triangles congruent using the 4 cases of congruency, right? In the previous video, we realized that those cases were side, 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 side angle, angle, side angle, side, and our right angle hypotenuse and our side, right? Now we're going to be putting that into action. Okay. Alright, technically speaking, the previous videos have just been like revision, and now we're getting into the real sort of work. So let's see, right? Okay, prove that the following pairs of triangles are congruent. Congruent is exactly the same. That's what we said last time, right? So is this triangle exactly the same as this triangle here? Let's see. Now let's look at it. It looks like I've got a side, and I've got an angle, right? So I can say now, I want you to watch how to write this out, please. This should be the only thing that you produce to me, right? So can we see now? Let's look at it. In triangle ABC and DEF, in triangle ABC and DEF, so the teacher knows that you are talking about this triangle here and this triangle here. I know at this stage it looks very, very simple. In fact, you know what, let me just go to something that looks a bit complex. Alright, there we go. In this case, I don't know which triangle you are looking at. I can see one triangle here, another triangle here, 2, 3, 4. Houses here, 5. Houses, fifth triangle, 6 triangles there. So I wouldn't know which triangle you're talking about. So you have to tell me, for example, if you're talking about PQS, you are talking about PQS. I know you are talking about that triangle. If you're talking about SRQ, I know you're talking about SRQ. There we go, that day, right? That's the reason why we name them, so the teacher can know what you're talking about, right? So we're back now, right? Now in triangle ABC and DEF, yes, okay, right, AB is equal to DE. We've got AB and DE is 33, right? We got that. Now this was given to us at this specific stage. We just an example 8, we're just entering this now. Most of the stuff is going to be given to us. We're going to see later on where it's not given to us. Let's look at angle A is equal to angle D. Both are 44 degrees. This was given to us. It's on the diagram. AC is equal to DF. There we go. 52, 52. This was given to us. Therefore, don't get rid of this line. Okay. Therefore, can you see this therefore sign? Let's look at it. It's just like 3 dots there, right? Forms sort of a shape of a triangle like that. Wow, too thick. Okay, so therefore, can you see we got our side here, we got our angle here, and we got our side. Therefore, triangle ABC is congruent to DEF. Side, angle, side. Now your marks would be here, 1, 2, 3, for saying this correctly and for your reason, right? For this whole entire line, 1 mark, whole entire line, 1 mark, line, 1 mark. For saying that, for naming this correctly, I'll show you what this means now, and for giving your reason. Please, this is very important, eh? Very, very important. Now, what am I saying about this? We said triangle ABC, ABC, right? So if you look at it, this is what I'm thinking in my mind now. I've got a ABC, so I went to a 33, the line that doesn't have any measurement, then a 52. 33, nothing, 52. Let's see, do we have a 33, nothing, 52? Let's go this way. No, that's nothing. Yeah, let's see, 33. Hey, we got 52. No, we said 33, nothing, and then 52. I'm teaching you how to think now. Let's see, 33, nothing, then 52. Yes, there we go. We're gonna be moving this way. Can you see like that? So it's D, it's E, and then it's F, DEF. That's how you name it, right? So let's go to example 9. Okay, example 9. I think I can speed up here, right? I think I can definitely speed up here. Here we can see we got two angles and we got a side, right? So we can have a side angle in a specific case, right? We can see that C is equal to F, B is equal to E, and CB is equal to FE, right? All of that is given down here, right? They ask you which angles. Let's look at that. Which corresponding angles are equal. We gave the angles. I just mentioned that to you. BC is equal to EF, and because of that, we got our side angle. Watch the wording. Watch the wording. Let's look at D. Okay. Now, in the exercises coming up, you're going to be having this here. Double shift from the C to the D. They ask you to prove that these two triangles are congruent. We proved them. I just showed you. Then they say show that AC is equal to DF and AB is equal to DE. Watch this. I want you to realize this. I want you to wrap your head around this. I've shown that these two are congruent. What means congruent? Congruent means that they are exactly the same. So this and this is exactly the same. So let's look at it. Now, if I take my pen now, what am I saying to you? I'm saying to you now, we can definitely conclude that angle A is equal to angle D. We can definitely conclude that AC is equal to FD. So what am I saying? If this was 13, this would be 13 as well. We can also conclude this, that AB is equal to ED. We can conclude that, right? Yeah, so we know that all the sides and all the angles are definitely exactly the same. They are all they correspond with each other. That's a more correct word to use, right? So in saying that, we can say for the answer for D, the question is show that AC is equal to DF is equal to and AB is equal to DE. We're saying yes, that's the reason why. Why is that so? Because they are congruent. We understand that if they are congruent, that these correspond. Look at this. If they are congruent, this and this, that pairs. AC DF. Let's look at it. AC DF. Can you see that they are equal? I put my 1/ there. Yes, that's what we are saying in words. Now once again, it's very easy to look at what I'm doing here. Sorry, it's very easy to look at what I'm doing there, right? But I need this from you. This is what I need from you. This is what the teachers mark. We need to see our statement and our reason why, right? The same story with AD is equal to angle A is equal to angle D. A is equal to angle D. Yes, you can say that these, let's zone in. You can say that they are congruent. Yes, I've shown you above how that would work out. And we have sum of angles of a triangle. This is not a very good example to show that. But what we're trying to say is, if I gave you that this here was 60, if this here was let's do something but looking a bit more realistic. Let's say if this was 120 and this was 120. If this here was 30, this was 30, then you would have used your internal angles of a triangle to find out A and to find out D, right, in that specific case. Okay, wow, I didn't see that my explanation was actually already down here, right? Like what I told you, if this was 130 and if this was, okay, this they use 20 here, we can use the internal angles of a triangle and figure out that's 30, right? Let's see if you don't trust me. Lots of learners don't trust me. I'm joking, right? 180 minus 130 minus 20, 30. That's how we got the A was 30. That's how we can get the D is 30, and that is how this reason here would stand, right? So let's go further. Okay, let's look at example 10. We're looking on page 158, right? So example 10. Can you assume that angle P and angle R are right angles? There's angle P, there's angle R. Can you assume that these are right angles? No. Why? You cannot assume that something, yes, it looks like it's 90 degrees, but you can't just assume that it is 90 degrees, because they must give it to you that this is 90 degrees, then we can work with that, right? So obviously there's your answer there. These angles are not indicated as right angles. Can you assume that Q1 is equal to S1? Q1, can you assume that this Q1 is equal to S1? Now immediately Rene is going to say, hey sir, I can see the Z here. Okay, that went a bit crooked there, but they're going to say immediately, sir, I can see there's my Z here, I'm excited. Now when you're going to write your reason, you're going to write that angle Q is equal to angle S, but which lines are parallel? Can we say that PQ is parallel to SR? No, we can't. Why? They did not tell us. No way on the diagram did they tell us. Now obviously we've done examples where we see that things can take properties, like if I tell you that this is a parallelogram, immediately once I tell you that this is a parallelogram, you've seen what I've done in the previous videos, we start to add in these properties here. If I told you that's a parallelogram, here they didn't say that, they just said consider this, just look at these two triangles. That's what they said, right? So they didn't give us this bit of information with parallel lines, etc. So no, these angles are not indicated as equal. All right? Can you assume that Q2 S2 are equal? Yes, we can. Why? We've got a dot there, we've got the dot there, these two angles are equal, right? Then we have which side is common to both triangles. Now remember, we're looking at this triangle here and we're looking at this triangle here. Now which side is common? I hope you see that this side here, this side here is common. This QS belongs to this triangle here, PQS, and it belongs to RSQ. It belongs here. So this line is common, right? So SQ, yeah, SQ is common, right? SQ we're going to E. Which sides are equal? Okay, sides are equal. There we go. PS is equal to QR, right? Sides are indicated. Sides are indicated, right? So prove that PQS is congruent to RSQ. So let's take that out. PQS is congruent. Look at congruence here. RSQ. Let's see this. Now, okay, I can use my highlighter to explain. Let's zoom into this and let's try and figure this out. Now, we know we're looking at side angle, etc. I have a side. Can you see my PS and my QR? I definitely have a side, right? Let me just write here that I will have a side. There's my side there. I definitely have an angle. What's happening here? I definitely have an angle, right? Now, do I have another angle or side or whatever? Hope, can you see it? Can you see that this is common? This is common. There's another side. This SQ belongs to this triangle and it belongs to this triangle. So SQ is common. Let's go here. There we go. Yeah, there we go. PS is equal to RQ, right? You will have all that above. I'm interested in this. This is something a little bit new to you. QS is equal to SQ, common side, right? Even if you tell me QS is common, I'll accept that as well, right? And therefore, we wrote out our proper naming. We taught you how to name it and our reason, right? Let's see what G asks. Prove that angle P is equal to angle R. Angle P is equal to angle R. We know why. Why is angle P equal to angle R? From our previous example, we're saying that, let's get that, we're saying that, here we go, because the triangle PQS is congruent to RSQ. Right, let's look at example 11. We're looking at page 159. So here, long story short, they want us to prove that these two triangles are congruent in two different ways. Two different ways that they show you here is one that you can see is your right angle hypotenuse and your side. Right, there's my right angle there, and this becomes my hypotenuse. Now there's a slight problem on this side here, is that I don't know that this is a right angle. Now if we use, let's zoom in here so we can see a bit more clearly. Okay, if we use this a straight line, right, a straight line, so this is 180 minus 90, we'll figure out that this here is 90, and then obviously that's an hypotenuse, and your answer is shown there. Alternatively, we've got that AD is equal to CD, right? Okay, that's given there, right? And you can read that there, right? So, okay, like I'm saying now, yes, you can read the answers there, right? I've done this too many times in the video. Prove that BD bisects D, right? BD bisects angle D. Let's look at our answer. D1 is equal to D2. D1 is equal to D2. You would have realized that from showing that these two triangles are congruent. Where is this? Let me get that. From showing that, remember from the previous example, if the triangles are congruent, the triangles are exactly the same. So the corresponding angle for D1 was D2. So that's why I'm saying that D1 is equal to D2, and therefore BD bisects D. That is my reason. So now I think this can also be a segue to show you I cannot say anything in C. Say the answer for C, I cannot say anything there until I proved above. Then I can use this information. I can use this information here. So what am I saying? If you never showed me the working out in B, you can't get your mark for C, right? Okay, then you would have done exercise 4. Okay, look at example 12 now. We see that we've got this figure here, right? And we see that, okay, there we go. We know about all the stuff here now, right? We know about all the stuff here, and we saying that this these two triangles are congruent. Now because these two triangles are congruent, we know now that from here to here is equal to here to here. So what can we conclude? That they have bisected each other, right? That CE is equal to C, right? So like I was saying, we concluded that this here AC and CD are the same, so they bisect each other. We're also going to realize by proving that these two triangles are exactly the same, but by proving that these two triangles are exactly the same, we realize that EC is equal to CB, right? So we can conclude that EB is bisected at C, right? Then you would have done exercise 5. Right, now we're going to similar shapes.